So this is Unit 2, Module 3, Lesson 1, while loops. There is a fast start activity and code to download, so go ahead and do that now. Pause the video. So today we're going to talk about a very important control structure, the while loop. This is the syntax for the while loop. While this condition is true, do these statements. So while x is greater than -1, execute these statements. This means this while loop could go on forever. While loops have the ability to go into an infinite loop, which means it's important that you pay attention to your condition and you don't put your computer into an infinite loop. Infinite loops are not good. There should always be some way out of the loop, even if it's something as simple as press enter to exit the loop, or in this case, they're going to enter in a -1 to exit the loop. We'll actually use this as a condition a lot, just testing to see if they typed in a -1 to check to see if they want to end the loop. So the while loop, programmers need to repeat codes. The syntax is a true condition and then multiple actions. You want to have the curly brackets here. You don't want to end up doing the single line statement here again for the same reason that we do it for the if statements. It gets very confusing. But you can do a single line statement. As soon as the condition becomes false, then the loop will stop. So essentially what happens here is, in terms of this flow, check the condition, do the statements, go back up here, check the condition. If the condition is false, it jumps right from this curly bracket to this curly bracket. It does not execute the statement. So it functions a lot like an if statement, only it repeats the actions over and over again. As long as the condition is true, it's going to complete those actions. So here's another example. In this case, we're incrementing C. It's essentially keeping count of the number of times people entered in a value. This is a good way of keeping track of things just by adding in a counter to your loop. You could actually enter in a counter and make that part of your condition. You know, if x is greater than -1 and C does not equal 50. So you're giving them some type of limit on their condition. We will get to another kind of loop that allows you to count specifically. So a while loop structure is not the structure you use if you know exactly how many times you want the loop to run. So if you want the loop to run exactly 50 times, we have another structure. What I'm talking about is you don't want someone to do multiple conditions in this case. X has to be greater than -1. And we're not equal to 50. So essentially what that says is somebody could keep entering in values, but they can enter in at most 50 values. They could enter in 10, they could enter in 23. This other structure I'm talking about would be guaranteed 50. You couldn't do anything else. It has to run 50 times. So we'll talk about that structure later. So here's what it runs like. You entered a 0, it says 2. You entered a 2, it says 3. You entered a 3, it says 4. You entered a 4, it says 5. You entered a 3, and it says -1. You entered in, I'm missing a space there, 5 values. Okay? One of the things that you have to get used to is counting the number of times a loop iterates. So when we look at this, essentially, we're looking for how many times is the condition checked. Here, the condition is checked 4 different times. So when we first start, 2, 3, 4. Then the last time they entered in a -1, so that's the last time the loop ran all the way through. So we're counting essentially trues. How many times was this condition true? Ah. Happy Halloween. So, okay. So, in this loop, we're putting in a C minus minus at the end of the loop to fix it from counting one extra value. In the last loop, it counted all the way up to 6. We actually want to make sure it only counts up to 5. That's one way of fixing it. Another way to fix it is put the C++ in a different spot. Change where it increments. Another way to fix it is start C at -1. So your starting point and your ending point for counters inside loops is going to be important. You want to pay attention to that to make sure it's giving you the exact result that you expect. It's ending where you expect it to end. It's starting where you expect it to start. And you might have to put in an adjustment. And sometimes order does matter. If they put in a C++ and increment it first, sometimes that makes a difference. So in this case, if we take a look at it, they're doing sum plus equals x. When they do the math here, we're subtracting C++ at the end, so we fix that, but we're still adding in whatever they entered. What's that going to do to this code? So what's happening here is it's adding in every value that the user types in, but when the user types in the stop condition of -1, it's adding that to the total as well. So our total is actually 1 smaller than we want it to be. So in this case, if we switch the order, or put in a condition there to make sure that it's not -1, that solves the problem. So by putting that little condition there, we fix it, and it doesn't accidentally add in the -1, which does the stop. It really is distracting. Okay? That's really the last time I'm going to tell you. If you guys have a question, ask a question, but I hear this low, deep voice coming from that side of the room, and it's really distracting. So please stop. So I'd like you to go ahead and calculate an average. Give that a shot. You have most of the code here to do it. Pause the video, and then we'll show you the solution. So here is the original code. This is the new code. All we did was add in the line, sum divided by C, and we have to cast this as a double in order to get our division to work, because we're expecting a decimal. We want a decimal there. It's an average. We get no round off error because everything was done as an int. And the only time we actually do any type of calculation with a double, it's just a cast there in the print statement. So we won't get a round off error. So while loops are a little bit challenging to understand, that's where this comes in, the Java visualizer. If you go into the Java visualizer and execute code, it will end up showing you step by step what is exactly happening. So I'm going to go ahead and type some code real quick. Type the code real quick. Ta-da. And if I'm going to click on visualize execution, hopefully I don't have a compiler error. There we go. So I can step through this code step by step. Now notice there's 308 steps. We're not going to go through all 308. But we can follow this execution of this loop, and it does something nice. It gives you the values of the variables as you step through. So x started as 100. Subtract 1, x is 99. Now watch how it bounces back and forth. Now technically it is printing out, oh, I'm missing my brackets. So I do have a little typo here. It's only doing this part of the loop. So after it finished the loop 100 times, it'll say, I like to dance. I meant for it to say, I like to dance 100 times. So let me fix that real quick. So we're going to go forward. Now you can see it's going through and giving me the print out as well. And I can watch X count down. Tells me what lines I'm going on. You can see that we're going through and looping through those lines. But it's nice because it kind of gives you a way of keeping track of what's going on inside your loop. And it will also be helpful when we start tracing code in the next section, so you can start to find patterns. So like if I said after 70 times, after this ran 70 times, what would be the value of X? Aha. So now the question is it 70? Is it 69? Is it 71? So by using this, we can follow a pattern. First time through, it's 100. Excuse me, at the end of the first time through, it's 99. So that's one run is 99. 2 runs is 98. 3 runs is 97. So the number of runs subtracted from 100 tells you the value of X. So you can say definitively after 70 runs, the value of X will be 30. Because you found the pattern. That's one of the things that we're going to do when we trace code in the next section, and this will be very helpful in doing that. I recommend throwing your loops into Java Visualizer just until you get familiar with it. And if you're trying to debug your code and you can't figure out what's wrong, this is a good place to check that out and put your code in. All right, we can jump to the last and can see, boom, we got 100 times X is -1. Interesting question, what would be the value of X? Well, it's -1, but just before this, it would be 99, right? Okay, jump back in. So now you try. I would like you to write a while loop. That will print Java to the screen 5 times. I kind of already sort of showed you how to do it. But go ahead and do that on your own and then submit it to the U-try.